The possibilities are endless for stars inside of stellar metamorphosis. Here's a new paper I have, the locations of K2-33 and K2-33 Bravo on the Walensky-Taylor diagram, as well as I have Victor 391 Pegasi Bravo, the red giant survivor. Essentially, the establishment says that K2-33 and K2-33b are, 9.3 million years old. And this paper is already on Vixar, so you can pull it up and read it along with me. I have K2-33 as being about 140 million years old per this diagram, so it's right about up here. It's a bit wide for a red dwarf. And then you have K2-33 Bravo. That's between 800 to 1.6 billion years old. That's down here. That's like a gray dwarf. It's in between a Jupiter and a Neptune-sized object. Let's see here. I also have a comparative little graph here. Here's K2-33b, its actual diameter. And then you have Pluto, Mercury, Mars, Venus, Earth, Uranus, Neptune, Saturn, and Jupiter. So it's between, Saturn, Jupiter, and Neptune and Uranus. It's a very, very evolved object. Not as evolved, relatively speaking, as the Earth, but definitely between Jupiter and Saturn. That being said, 9.3 million years versus 800 to 1.6 billion years, there's a big difference there. They're off by 2 magnitudes. That's a big, big, big problem. And what's even worse, as I write it down in this, is that not only do they have the ages wrong, both the objects are too young, they have them the same age, even though they're clearly different in physical characteristics. How can you have 2 objects that are clearly different in different stages of evolution, which are obvious to the people who understand this theory, and force them to be the same age? It's really strange that the establishment does that. Because I have this really cool diagram here. This isn't to scale, but this is what is called the new Scorpy system. The new Scorpy system has 7, by their definition, stars all orbiting each other. Check out how advanced, how crazy that is. Look at that. You have big A and small a, big A and small b, big A and small c, and then you have B, and you have C, big D and small a, and big D and small b. Check that out. Look at how different all those probably are. You have your large blues, you have your suns, you have your smaller blues, and you have a red dwarf hanging out there. Now, by their definition too, red dwarfs are very old stars. And then you have these bright blue stars in there which are very young. How do you suppose they're going to determine the age of these stars? Are they gonna force them all to be the same age because they're in orbit around each other? I don't know. It should be very interesting over the next couple of years, because the way they look at the solar systems, the star systems, is that they take the object with the most mass, and anything that orbits it must be as old as the object in the central regions, or the object with the most mass, which is really weird. That's like looking at Jupiter and saying, well, we know Jupiter is around 350 million years old, and saying, well, Ganymede, Io, and Callisto are, also 300, are also the same age as Jupiter, when there's no way that those rocky objects that are differentiated formed at the same time as Jupiter. Jupiter is clearly a lot younger than them. See, the Jupiter's moons are also remains of impacts and are dead stars themselves, way the hell over here, and even probably down here. I didn't include some of the objects that could be down here somewhere underneath the main evolutionary sequence here where life forms. But it's just, you just have to be very careful of that. You have to be very careful of accepting ideas just because they appear to make sense. When you examine them, they fall apart. You can't take the sun and say, well, everything that orbits it is the same age as the sun. That's very, very poor reasoning. Because, I mean, just look at the objects. They're all different. How can they all be the same age? That's impossible. I don't know why they accepted that. It's like going to a forest and seeing a large tree, and then you see a bunch of plants growing around that tree that are a lot smaller, and then the biologist or botanist saying, well, these small plants are growing around this large tree, so the small plants are the same age as the large tree. No. Just because they're in the same vicinity, it doesn't make them the same age. And it doesn't mean, well, you get the point. Continuing on, I have another, what I would like to call smoking gun with V391 Pegasi b. Now, V391 Pegasi is a sub-dwarf B star. It's a very hot blue star. I would say it fits probably about, here I'll get a larger picture, probably about right here. Now notice, there's no red giants in this graph. That being said, V391 Pegasi is a subdwarf which supposedly had to have come from a red giant. So there was a red giant, it lost a lot of its mass and then transitioned to its current state, which is a hot blue star, in this theory, a very hot young blue star. But to them, it's an extremely old star, and anything that orbits around it had to have survived Pegasi's red giant phase. And this is very problematic because they found a planet, a gas giant, circling really close to V391 Pegasi, and they just attached a small b to it. And they say that object, that gas giant that's orbiting it, survived its red giant's phase, which is really strange. I'm not going to read all these out, but I'm going to bring home this point. Number one, V391 Pegasi b, the gas giant that's orbiting the subdwarf, never survived its host red giant phase because the red giant phase never happened. This is the most likely scenario. And I'll read this out to you. This will be like saying, I survived a nuclear bomb being dropped on my hometown, yet it never happened. Surviving an event that never happened is quite easy. You can be a survivor of anything if you were never near the event or the event never happened. And that's the smoking gun portion of it. If this gas giant supposedly survived the red giant phase of its host, why is it still there? Why does it still have a thick gaseous atmosphere? They don't have any explanation for it. They just say, oh well, it survived. And then don't ask questions. Don't dig too deep into this. And that's not good science at all. Because there are a lot of other options that are available, and I list them on the bottom. I'm not going to read all of them out to you. But the most important part is you can say whatever you want. You can make an event happen, or you can say, what I mean to say is you can have anything survive anything, basically, and it will look exactly like it never happened at all. The two situations look exactly the same. Saying I survived, World War II, well, it will look similar. It was like, how could I have been there? Because I wasn't even alive, Surviving an event, was what I'm saying is, it looks exactly like that event never happening at all. And they never say that in any of the articles that I read about this. It's just always accepted. You either accept it or you know, to hell with you. You're a crank or a crackpot or whatever. Anyways, I just wanted to share that with you guys. Let me show this picture again. A seven young star system. Look at that. That is absolutely fantastic. I didn't even know this thing existed. I honest to God didn't. This just shows that, you know, we live in a very chaotic galaxy. This isn't a cut and dry, mathematically perfect place. This is a very random place and it's full of chaos, which is basically the opposite of what Carl Sagan's book was, Cosmos. Cosmos means, you know, perfection. Me, I'm more along the lines of chaos. I believe the 19th and 20th, or 17th, 18th, and 19th and 20th century astronomers, they became obsessed with mathematical equations, and it led them down a dead end because they were obsessed with perfection and measurement and getting everything in its order. But what mathematicians couldn't handle is randomness, infinities, and chaos. And that's what I think is needed a little bit more of in the 21st century so that we can understand these objects better. All right, you guys, today is February 6th, 2019. I'll go ahead and post this to the bottom so you can read it too. Later.